Hello and welcome to Lesson 12.7. Today we're going to look at experimental probability. The objectives for this section are to find experimental probability and we're going to show you how to use simulations to find experimental probability. Experimental probability really isn't much different than theoretical probability or anything else that we've been calculating, but the key difference here is experimental probability is the number of times an event occurs, but it's going to be divided by the number of times an experiment is done or completed in this case. So the way I like to think about this is if we look at theoretical probability, let's say of flipping a coin, we know that you have a 50-50 shot at getting a heads or a tails. Well, experimentally, if you flip a coin, let's say you flip a coin 3 times and 2 times you get heads and 1 time you get tails, that means that you had a 66% chance at getting the heads versus a tail. So experimental is kind of like what actually happens in real life. Okay, and it should be close to the theoretical probability, especially the more times you perform that experiment. But sometimes in the beginning, it's not always, it may not be that close to the theoretical. So we'll take a look at a couple examples here. So looking at example 1, it says a medical study tests a new medicine on 3,500 people. It is effective for 3,010 people. Find the experimental probability that the medicine is effective. Then what we're going to do is we're going to predict the number of people in a group of 6,000 for whom the medicine would be effective. So let's look at the first part here. So if I want to find the probability that this medication is going to be affected, I see that we've given it to 3,500 people, so that's going to be my denominator. So the 3,500 goes in the denominator, and it said that it's effective for 3,010 people, so that's going to go in my numerator. Now, if you wanted to reduce your fraction, this will reduce down to 43 out of 50 people the medication will work for. You can also look at this as a percentage. Okay, and to do that, remember, you're going to take the 43 and divide it out by 50. And if you do that, this is going to give you 0.86, which is 86%. So that tells you that that medication is going to be effective about 86% of the time. So for the next part, there's really a couple different ways that you can figure this out. It says, we want to predict the number of people in a group of 6,000. So now I'm looking at 6,000. So what we're going to do is we're going to start out with our 6,000 people. And you can do this in one of two ways. You can either multiply this by the percentage that we just calculated, so by 0.86. Okay, and if you do that, you'll see that you get 5,160 people. So out of the 6,000, this medicine is going to be effective on 5,160 of those people. Or what we could do is we could actually go ahead and take that 6,000 and you can multiply it by your fraction that we got in the beginning. And actually, it doesn't matter if you do the 43/50ths or the 3,010 over 3,500, but I'm guessing the 43/50ths is it will take you a little bit of time to get down to that. So if I multiply this by 3,010 over 3,500, then this here is going to give me 5,160 as well, because remember, I'm going to put that 6,000 over 1, then you're going to multiply the 6,000 and the 3,010, and you'll divide by the 3,500, and that will also give you the 5,160. Now, example 2 is very similar to example 1, so I would suggest that you pause the video, try to work this out yourself, and then continue to play it to see if you were correct. So for example 2, it says another medicine is effective for 1,183 of the 2,275 people. We want to find the experimental probability that the medicine is effective. So again, the probability is going to be 1,183 that it's effective for, out of a total 2,275. If you want to take the time to reduce this down, this will give you 13/25, or it tells you that it's effective for 13 out of every 25 people. Or if you just want to do the straight up division and figure out what percentage it is, this gives us 52% success rate. So now for part 2, it says, then predict the number of people in a group of 4,500 for whom the medicine will be effective. So if I take my 4,500 people, I personally like to multiply it by the percentage. So I'm going to multiply that. Remember, you convert percentages to decimals. So 52% becomes 0.52. And when I multiply that, I end up with 2,340 people are going to be predicted to have a success rate out of a group the size of 4,500. Now, the last thing we're going to look at in this section is something called a simulation. Okay, we're going to look at how to use those. So a simulation, as you can see, is a model that's used to find the experimental probability. Okay, so this would be like if you were in a lab setting or setting something up at your kitchen table that you could physically maneuver and do, and then go and calculate the actual probability. So we'll look at an example with that. So our last example says, to simulate the correct guessing of true-false answers. Okay, so that's the actual question. Now, a way that you could simulate this, and I do have this typed down below, is you could actually use a coin, okay, and toss it to figure out or to simulate true-false, because a coin has a heads and a tail, just like in a true-false question, you have a true and a false. So notice the heads represents a correct answer. So heads is going to be true, tails then, so I'll put this off to the side, tails equals false. Maybe I should write true here. Okay, so just to kind of keep this in mind. So what you would do is you would go, and you can try this at home if you'd like to see how close you are to what we get for the first experiment, is you're literally going to flip that coin 50 times and you're going to record the results. Now what I've got here is I actually have a table of 50 tosses. So you can see that here's toss 1, toss 2, toss 3, toss 4, toss 5, toss 6, 7, 8, 9, 10, and so on. And there are 50 of these. So now what we have to do is we are going to calculate, we can calculate the probability to see how close to 50%, which is our theoretical probability, how close to 50% we really are. So take a quick second and calculate the number of heads, because remember our heads is going to equal true. So when I counted, I got 22 heads out of a total 50 coin flips. If I reduce this, this gives me 11 out of 25, which is 44%. So you can see in this case, the theoretical we know is 50%, but my experimental, or when I actually started doing the simulation, I got 44%. So in this case, it was just a little bit less, and that's okay. Please let me know if you have any questions. Otherwise, have a great day.